will also share the screen. Okay. So this is where we stopped just before uh, we had gone for break. We had pasted our loadings onto the Excel. So the first thing that we will do is we'll compute the lambdas, and what is the formula for, like we did yesterday, we will square the loadings. So this is the square of the loading, and we paste the formula. So we have done square of the loadings now. Okay, right? So we have done lambda square. Now what do? We will compute the error variance, which is 1 minus lambda square, right? We do that. We this. Okay. And we will also do the sum and sum square. Right? So what is the sum of the lambda? This is the sum of the lambda. Right? And for the formula sum, and similarly sum of the error variance is this. Okay, and square of this sum is. Similarly, we'll do the same thing for Pj. So we'll do the sum of these 4 items. Okay, and sum square will be square of this number. Similarly, we'll do the sum of error variances for Pj, which is sum of these 4 numbers.
Just a minute, Professor Vishal. Some of them are not able to see the screen.
Still?
It is visible to me.
No, I think they will be able to see it now.
Please write yes. I think everyone is able to see the screen. It's okay. Perfect. Go ahead, please.
Okay. So now we will do the sum of the lambdas for CPP, which is these 4 items, and sum square, which is equal to this, this, and we will also do the sum of the error. Just to differentiate, just take this. Right, so this is these are the numbers. So we will first compute the average variance extracted for leadership, which will be average of the 3 lambda squares, okay, which is going to be this, right? This is, and the CR is going to be sum square divided by sum square plus the sum of error variances. So this is ADE. This is, sorry, this is CR. ADE we had computed earlier. Now we will look for PJ. So we'll again do average of lambda squares. These are the lambda squares. Okay. So, and we CR, which is equal to sum square divided by sum square plus the sum of variances. This becomes the CR, and now for CPB we will do average of the lambda squares and composite reliability. We will take the sum square divided by sum square plus the regular. This becomes a CR4. So now if you look at test for convergent validity for lead, right? We are saying that our CR is greater than 0.70 and ABE is greater than 0.50. Right? For PJ, we are getting CR greater than 0.70, ABE greater than 0.64, and for CPB, we are getting our CR greater than 0.70, ABE. Now ABE here is equal to 0.45. So it is not greater than 5.50, but it is okay at around 0.45. And more importantly, because CPB is not the construct for which we are developing the scale, we are more interested in the scale which we had developed, which is ABE greater than 0.50. Now it may so happen, actually in my experience, what can happen is that your CR may come out to be greater than 0.7, but ABE may actually be less than 0.5, just like what we have. So don't worry at that point. If your alpha, you see for we have reported CR, you will also report your Cronbach's alpha. Okay, if both of them cross 0.70, just like here, then you can say that there is convergent validity, even if AB is not greater than 0.50. That is okay. You can just go ahead and say that the items, you can only report composite reliability and say that we are getting good result for our for the scales that we are using. Right? Remember, even if you are using validated scales or already published scales, you will always compute reliability again. Right? You will always be computing reliability again. So composite reliability you will always report, even ABE you will always report. This convergent validity thing you will report, because for the construct you will call these conditions as conditions of convergent validity when you are testing your scales, right? When you are developing your own scale, you will sort of mention this as a, you will, otherwise you will not use convergent validity. You will just call this as that CR was greater than 0.70, and therefore these items are good measures of the latent construct, right? So if it is, so as I mentioned, if alpha and CR are greater than 0.70, good, and just go ahead and ideally speaking, yes, good journals will want to look at these numbers satisfying these conditions, but if you don't get it, there's nothing that you can do. Okay? So this is on convergent validity. Now let us go and do the next one, which is discriminant validity. This is more important, and this is where ABE has a bigger role to play, and this is where we are going to use it now. So we are going to construct a table like we had constructed for the 3-dimensional sphere of leadership. So now we will talk in terms of construct, because we want to talk about construct level discriminant validity. So we'll talk about lead, we'll talk about PJ, and we will talk about CPD. Instead of yesterday we had done it for individual dimensions. Now we are doing it for construct level, right? So this is our factor 1, factor 2, factor 2, and this is our factor, right? And similarly here also you have, we call this as F1, F2, and F, right? So this is all that we have for convergent. So this is our convergent validity. This table was convergent validity, and this table is discriminant validity, right? Yeah. Now, what is the diagonal? Diagonal values are going to be AV values. So we will copy these. This is AV of leadership. This is AV of PJ, and this is AV of CPD, right? That is how. Okay. Now, below the diagonal, remember we said it will be correlations between factors. And where will we get the correlations between factors? This is where the measurement model output will come in handy, and we want to look at, yeah, this is the measurement model output. Go to estimates, go down, scroll down, and you will get correlations. So the correlation between lead and PJ is 0.535. So correlation between F1 and F2, lead and PJ, is 0.53. Correlation between lead and CPD is 0.35. Okay, and F2 and F3, that is PJ and CB, PJ and CB, it is 0.296. Which is 0.36. So the diagonals are AV of constructs. Below the diagonal, these three are, okay, these three values are inter-factor correlations, and above the diagonal are going to be, let us choose another color. Above the diagonals are square of inter-factor correlations, right? And what is going to be the square of inter-factor correlations? This multiplied with itself. This is square of this with itself is this number, and this multiplied with. Right, so we have now filled in this table of discriminant validity. We have the diagonal elements, below the diagonal, and above the diagonal. So what is the condition 1 for discriminant validity? AV of lead should be greater than square of correlation F1, F2, and square of correlation F1, F3. Condition 2, is AV of Pj should be greater than square of correlation F1, F2, wherever F2 is going to come in, and square of correlation F2, F3. And condition 3 is going to be AV of CPB should be greater than square of correlation F2, F3, wherever F3 is coming, and square of correlation F1, right? These are the three conditions that we have to check and prove that the construct measured by our scale is discriminant from the other measure, right? So condition number 1, AV of leadership greater than square of correlations with F1, F2 and F1, F3, and this condition passes. The second is AV of Pj should be greater than square of correlation F1, F2 and square of correlation F2, F3. This condition passes. And the third one is AV of CPB should be greater than square of correlation F2, F3 and square of correlation F1, F3. And this condition also passes. And what do we conclude therefore? So the conclusion from this test is that the leadership construct measured through our scale, right? I am highlighting this word, our, the scale that we have developed to our scale is discriminant from other constructs which are theoretically determined, right? So this is or theoretically suggested, right? So we know that leadership is not the same thing as PJ. Leadership is not the same thing as creative performance behavior, right? So this is what we are. So this is what we are concluding from our test result, right? And therefore, our scale, our instrument is a good measure of the construct that we are developing or the construct that we have in mind for which we are doing this exercise. So this is convergent validity, discriminant validity, and now we go